Hello guys, and welcome back after the break. Now we've looked at area and we just calculated the area of this grid in square kilometers, and we've got an answer of 19 square kilometers, as you can see on the bottom of the slide. A very popular question regarding area and that they ask you to go and calculate is the area where the orthophoto has been covered, as you can see over there. Now I want you to go and have a look on the map that we scanned in and see where this area is. Now the area where the orthophoto has been covered is this area over there. So many times they do ask to go and calculate the area that is covered with the orthophoto in square kilometer. So basically what you need to go and do, you need to go and calculate your length with your ruler, your breadth with your ruler, but keep in mind, because we're working on a topographical map, you need to times it with 0.5 to get kilometers and 500 to get meters. Now let's just quickly go and do the example on our slide, and I just need some extra space over here to do it. Now hopefully you will be able to do this by yourself by now. If we look at the area covered by the orthophoto, let's quickly go and measure this distance over here. Okay, we won't be able to, but let's go to the map quickly and try it from there. So we go and measure the length. Oops, touching with it. As you can see, the length is 10.5 centimeters and the breadth is 8.5 centimeters. So let's quickly go and calculate it. So area equals length times breadth. The length was 10.5 centimeters. Let's presume they asked the answer in square kilometers times 0.5 times 8.5 centimeters times 0.5. Once again, you get your calculator out. 10.5 times 0.5 equals 5.25 centimeters, and then 8.5 times 0.5 equals 4.25, and to calculate your the final answer, it's 5.25 times 4.25, and you get your answer in square kilometers. It's 22.3 square kilometers, and that's your final answer. Now grade 12s, keep in mind, a question can be asked to calculate the area on an orthophoto map. Now by now you should know orthophoto's got a different scale, 1 to 10,000. If I want our answers in meters, we times it with 100. And if I want my answer in kilometers, we times it with 0.1. Now let's just quickly go and have a look at the example over here. Keep in mind you need to use this formula. Now keep in mind, area's formula doesn't change, but when we go and calculate the centimeters, we're going to use a different formula because we're using a different scale. Now let's just quickly go and have a look at our orthophoto. For instance, this area there. Oh, let's just zoom in over here. If you can see this area P situated over there, you can see there's quite a square shape area situated on the orthophoto. Now that can be a recreation area such as a rugby field or soccer field. Now the question might state, go and calculate the area of P in meters or kilometers. Now let's quickly go and calculate the area of P in meters. So we measure the length, as you can see, 8, 9 centimeters. We go and measure how wide it is, and as you can see, it's 4.5 centimeters. We said area equals length times breadth, so the length was 9 centimeters. Now remember, the map that we used was the orthophoto, and it consists of a different scale, 1 to 10,000. So if I want my answer in meters, I'm going to use 100. So it's 9 times 100. And then we said 4, it's 4.5 centimeters wide times 100. Now let's just quickly go and do the calculation by using our calculator. 9 times 100 gives me 900 times 4.5 times 100 equals 450. And our final calculation to calculate area, 900 times 450 equals 405,000 square meters. And hopefully that will cover area and how to go and calculate area on an orthophoto map and a topographical map. Remember that because of the different scale, we use different units to calculate the length and how wide the object or field is. Now, our next topic that I want to discuss with you is gradient. Now, when you think about gradient, we think about the steepness of a slope. We want to see how steep a slope is. Is it the gentle gradient, that's a flat area, or is it the steep gradient, where there's a huge inclination? Now, very importantly, when we look at a map, it's a flat surface. We can't determine the height on the map because it's a flat surface. So what do we use to show us height on the map? The first reference that we use to indicate height is a trick beacon. Now, very importantly, on a trick beacon, there's two numbers, the trick beacon number and the actual height. Now, very importantly, when we show height, that equals altitude, we measure it in meters. Now, for instance, let's say for instance we go and climb Kilimanjaro. We don't say the summit of Kilimanjaro is 5.5 kilometers high in altitude. We refer to meters, 5,500, because the unit of kilometers is just too big to use. So we always express altitude in meters. Now, to show us altitude, a trick beacon is the first example I can use. For instance, as you can see over there. Now, very importantly, there's two sets of information with a trick beacon. The 352, it's in bold and printed in italic, is the trick beacon number. It's not the actual height. So the actual height is the 594.5. That means this trick beacon is 594.5 meters above sea level. Please, matrix, don't get confused. The bold italic number is the trick beacon number and not the actual height. If I can use another example quickly on this map. Over there, you can see the bold italic number is trick beacon 162. That's the trick beacon number. And the actual height, the altitude above sea level, is 648.7 meters in altitude. Now, our second reference that we use to represent height is a spot height. Now, we've dealt with them a couple of times when we did calculations, and as you can see, there's a spot height situated over there. It tells us it's 658 meters in altitude. Just to show you another one. There's another one, 591 meters in altitude. Thirdly, that we use is contour lines. Now, contour lines are lines joining places with equal height. If we go quickly to our map, a beautiful example where you can see lots of contour lines is in block A1 and A2. All these brown lines represents lines of altitude, and they are known as contour lines. And what we've learned in the previous lesson, contour lines got an interval of 20 meters. The interval on a topographical map is 20 meters. The interval on an orthophoto map is only 5 meters. So all these lines that you see over there in this grid is known as contour lines. Now lastly, that we usually find to show us height is benchmarks. A benchmark is usually a road that goes through a pass, and next to the road there will be a small sign showing you the height. For instance, 1,400.7 meters above sea level. Now once we look at gradient, there's a relationship between height and distance, because what we're trying to establish over here, we want to see how far do we need to travel before the gradient increases. Now very importantly, coming back to our measurement of gradient and height on a map, as you can see, it's always expressed in meters. Now my first tip to you, if you calculate distance on a topographical map, you times it with 500. And if you calculate distance to get your answer in meters on an orthophoto, you times it with 100. So once we calculate, if you look at gradient, we want to see over which distance does the gradient increases. Now keep this in mind. When we calculate meters on a topographical map, 500, on an orthophoto map, 100. Now let's continue looking what the nose tells us. It's a relationship between height and distance. Now how do we calculate distance in meters? 500 on a topographical map, 100 on an orthophoto. Now the gradient basically tells us how steep it's in a straight line from one area to another area. Now if you look at the formula of gradient, very importantly, gradient equals the height difference over the distance. The height is the vertical movement from one point to another point, and the distance is between the two areas. How much is the gradient increasing between the one point and another point? So in short, that's our formula. Gradient equals height over distance. And what I usually tell my learners is, it's usually the height difference, because you need to establish what's the difference between the one point and another point. So we need to establish it. But very importantly, when we calculate the difference between X amount and Y amount, what do we need to do? We subtract. It's very simple. We can't go into a minus. For instance, let's say you have 20 apples and I have 25 apples. What's the difference? Only 5. It can't be minus 5. I only need to know the difference between what you have and what I have. So let's say, for instance, you have 55 apples and your friend's got 65 apples. What's the difference between the amount? 10 apples. And keep in mind, we can't go into a minus once we discuss height difference. Now, I'm quickly going to give you an example regarding gradient and how do one go and calculate it. First of all, there's your definition. Formula. The gradient equals the height and the distance. Now just a tip, how do we express distance with altitude? In meters. Because we calculate gradient, keep in mind we use the formula for meters. And you know, a 1 to 50,000, to get meters, you times it with 500, and a 1 to 10,000, you times it with 100. Now let's quickly go and look at an example. Let's say, for instance, I ask you, calculate the gradient from tree beacon number 2 to spot height (1,400). Now grade 12s, be very careful. Tree beacon number 2 means the actual number. Now if you can remember, it's the bold italic number. So let's assume this is my map down here. Let's continue. This is my topographical map, 1 to 50,000 map. And let's call it the map of Durban. So the question states, calculate the gradient from tree beacon number 2. So I'm going to try and make this bold and italic, a little bit fatter. And the actual height is 2,400 meters. To spot height 1,400. Now importantly, go and look at your formula. Gradient equals height over distance. But we need to establish the height difference. So first of all, let's just quickly go and draw a formula in here. Let's use a red pen instead. So already we got the height difference. We can establish what's the height difference. And how would you do it? You subtract the lowest from the highest. So in this case, if we quickly have a look at it, it's 2,400 minus 1,400. So we already established the height difference, the difference in height between the two references that represents height, the tree beacon and the spot height. Now, if you look at the formula, the D represents distance. So you use your ruler and you measure the distance between the tree beacon and the spot height. And as you can see, it's 23.5 centimeters. So 23.5 centimeters. Now we express gradient in meters because the kilometer unit is too big to use. And if we look at our map, it's a Durban map, 1 to 50,000. So what are we going to times it with? 500. So what are we going to do? Quickly get out your calculator. 2,400 subtracting 1,400 equals 1,000. And then what we do, 23.5 times 500 equals 11,750. Now, very importantly, when we calculate gradient, we need to get a ratio of 1 because we want to see how many meters and what distance did the gradient increase by meter. And to get a ratio of 1, we need to divide 1,000 by 1,000 because that will give us 1. Now, to get a ratio of 1, what do we do? If we want a ratio of 1, what do we do with a million? We divide a million by a million. if we want a ratio of 1, what do? And we got 50 as total. We take the 50, divide by 50, and that gives us 1. So what do we need to do? We need to get a ratio of 1. And what's a simple rule of maths? What you do on the top, you need to do on the bottom. So 1,000 divided by 1,000 give me 1. And then lastly, you say 11,750 divided by 1,000 gives me 11.75. So basically, when we walk from this distance to that distance, it means from there to there. For every 11.75 meters we walk, the gradient increases by 1 meter. So for every 11.75 meters we walk from spot height 1,400 to trick beacon number 2, the gradient increases by 1 meter. So we need to walk 11.75 meters for the gradient to increase by 1 meter. Stay tuned, and we're going to continue after the break.